Hello learners, previously in Form 2 and Lesson 4, we were dealing with determining the relative atomic mass, R.A.M, given percentage abundance. But now in our Lesson 2, in our second, we are dealing with determining the percentage abundance. In this case, you are given the relative atomic mass. Okay, example 1. Lithium has two isotopes with mass numbers 6 and 7. If the relative atomic mass of lithium is 6.94, determine the percentage of each isotope. So how do you write lithium? First of all, lithium is written Li. So write the chemical symbol aside, Li. Then you write the mass number, the first mass number as your here, 6. So we don't know the percentage abundance. We can take the percentage abundance to be X. Okay, next, half the other one again, and the other one, because we are told it has only two isotopes, we can say it's having a mass number of 7. But what about its percentage now? The percentage will be 100 minus X. Remember, percentage is 100. So if you have taken 1 as X, what will be the other one? It will be 100 minus X, because we want, when we take X and we add 100 minus X, we want to get 100 alone. So check, minus X and X, they go away. So we're having only 100. So if you take the first one as X, then the other one will be 100 minus X. That's the only hidden concept here. The rest are just very simple. If you don't want to take X, you can take Y, but this other side, it will be 100 minus Y. It's not must you to take this one X. You can decide to take this one X, but the other one will be 100 minus X. Okay, if it's like that, remember the formula that we were using to calculate relative atomic mass. Relative atomic mass, we were using mass number 1 multiplied by percentage number 1 divided by 100 plus mass number 2 multiplied by percentage number 2 divided by 100. So here, we are having our relative atomic mass as 6.94, which will be equal to my mass number, which is 6, multiplied by percentage number 1 here, which is X divided by 100. Kindly, if you are using X as your let, make sure it will be in a small letter, because this is multiplication. So if you put another X like this, you are having two X's. We will not differentiate which one is multiplication and which one is which one is X. So we say plus mass number 2, which is 7, multiplied by, open bracket, 100 minus X, close bracket, divided by 100. Okay. Let's just try to see. We are having here 6.94, which will be equal to, multiply this, it will be 6x over 100 plus. So this one multiply 7 times 100, remove the bracket, it will be 700 minus 7 times minus x, that's minus 7x. Minus is here, then 7x is here, so over 100. Okay. So you're having everywhere 100 here, 100 here. You can say 6.94 will be equal to, the LCM is still 100, then it will be 6x plus 700 minus 7x. Okay, thereafter, let's just try to write again. 6.94 will be equal to, then arrange your numbers like the one that's having x. So group the like times, it will be 6x minus 7x plus 700 over 100. So if I want to remove this 100, I can multiply here by 100, then multiply here by 100. So this 100 will go with that 100. So this will be 694, which will be equal to minus x plus 700. So what we can do is, we can take this negative x to be on this other side, so it becomes positive. It will be equal to 700, which is here, minus this 694 will go on the other side, 694. X will be equal to 6%. So if x is 6%, what about the other one? So we're going to say Li6 is 6%, and Li7 will be equal to 100 minus 6, which is 94%. So the percentage abundance of each isotope will be, lithium 6 will be having 6%, then that of lithium 7 is going to have 94%. So we're done with that one. We go to number 2. So here we are having the same. An element X has a relative atomic mass of 40.2. It has 2 allotropes, I mean 2 isotopes, not allotropes, sorry, of masses 39 and 42. Calculate the relative abundance of each isotope. Relative abundance means percentage abundance. So we are going to start the same. So what we have done now, so we can have X, then the first mass number is 39. So we can give this as X%. Then we can have the other one, which is having a mass number of 42. We are going to give 100 minus X. So our relative atomic mass is 40.2, which will be equal to mass number 1, which is 39 times X over 100, plus mass number 2, which is 42 times, open bracket, 100 minus X over 100. So from there, we can remove the bracket. We're having 40.2, which will be equal to 39X plus, we're having here 4200 minus 42X. We are removing the bracket, so you can put all this over 100. So you can say times 100 here, then times 100 here to remove this 100. So this one will be 4020 will be equal to 39 minus this. We are going to get minus 3. We're having minus 3X plus 4200. So let's take that one on the other side. We're having 3x. We're having 3x, which will be equal to 4200 minus 4020. So 3x will be equal to 180. So divided by 3 here, divided by 3 here. So x here will be equal to 60%. So if this is 60%, what's the other one? So that we are going to say X39 is having 60%. And then that means X42 is going to have 100 minus 60, that is 40%. Okay, we have gotten our answer like that. So next class, we are having extended questions. Try to attempt those questions. In our next class, we are going to be dealing with determining the ratio abundance instead of determining the percentage abundance. Next, we are going to deal with that. Thank you.